So good morning. My name is Sungwoo Lim. I'm a senior research fellow at the Open University. Today, I'm going to talk about the microwave heating demonstrator payload, also known as the MHD payload, on behalf of our colleagues at the Open University, Added Value Solutions, and Viper RF. And if you attended ELS annually, then you probably heard about this MHD payload already, because I've been talking about this payload concept for now 3 years. So since 2020, we've done a lot of experiment and development. So there are lots of things to show you, but we already showed something. And today I'm trying to show you the up-to-date result. And just in case you never heard about the MHD payload, so I'm trying to go through quickly what we've done at the Open University in terms of R&D. At Open University, we are actually trying to do in R&D work in threefold. And firstly, we try to continuously understand the microwave heating behavior of lunar regolith and simulant. To do that, we've done lots of lab experiment using lunar simulant on the air condition and also vacuum condition. And we found lots of interesting research outcomes, and we published that. We also done and continuously doing computational simulation, trying to understand the thermal runaway and the hotspot positions and the effect of the resonant frequencies and the volumes of the samples and the cavity dimensions, how they affect to the heating performance. To do such an experiment, obviously we cannot just use a simple domestic microwave. So we designed and manufactured the bespoke microwave, which you can see from the left side. It's the left side, right side of the picture. That is our bespoke microwave. And recently, we are also trying to extracting oxygen and water from lunar regolith. So we have also developed a gas processing unit on the right side. Sorry, it's the left side. The gas unit attached to our bespoke microwave. Using this equipment, we've done lots of experiments. The point is, whatever we've done is everything is simulation, because we use material as simulant, and our experiment environment also simulated. So you cannot actually tackle all the details of the real lunar surface environment and also material stuff. That is why we are currently developing microwave heating demonstrator payload. So the Open University teams up with the Added Value Solutions and the Viper RF. And since 2020 and 2019, we developed the payload concept, design, and budget. This is up-to-date design, and the currently maximum mass is 10.84 kilogram, and the peak power we require is about 450 watts. To develop this payload, we also need to focus on the various subsystems that include the microwave cavity and crucible loading systems and crucible storage and sample collection mechanisms, etc. And we're not starting there. We're also developing 250 watt of solid state microwave generator, because we don't want to use a magnetron on the very dedicated lunar surface environment. So we are focusing to increase the DC to RF efficiency of more than 60%. At the moment, it's around 62%, but this is not space certified yet. So after certified, we still want to keep this ratio or more. Now, thanks to the UKSA, we secured the funding from last December. Now we are actually manufacturing some part for the first prototype. So we manufactured the microwave cavity, received the end of last month, and we are actually manufacturing the microwave generator and hoping to receive it by the end of October. Until then, at the moment, we bought off-the-shelf microwave generator. This is also solid state and testing the heating performance of the new microwave. While we developing MHD payload, because our final aim is we're trying to develop lunar construction process using the microwave heating-based 3D printing, we're also trying to build another payload or platform we called microwave heating-based 3D printing platform. Yes. So what you see here is everything's up there. the schematic diagram of the MHD payload. So all the functional diagrams there. Because we are trying to simplify the concept, we're trying to simply add the 3D printing functionality in the MHD payload concept and realize the MI3DP platform. Obviously, at the end of the day, we want to focus on the swarm concept. So we will have a multiple small printing platform working together, making really large scale of protection cover or lunar habitat. But at the moment, it's just starting point. So we're trying to make everything is simple. At this stage, we are trying to use EBS as a foldable country. Because it's foldable, the footprint is small for the whole. And we can see the head was whatever. Let me just move to the next slide. As I mentioned before, we actually manufacturing the microwave cavity and microwave generator as part of the MHD payload. So what you see here is our microwave lab at the Open University. On behind, there is a bespoke microwave equipment. We continuously using it. On front, there is oxygen extraction gas processing unit. On the left side, we are now building the Barebone microwave heating unit over the MHD payload. If I zoom it, on the top space, this is a new microwave cavity recently manufactured for the validation for heating performance. On the bottom, we bought Kune's 450 watt of solid state microwave generator to test this cavity until we receive the 250 watt of microwave generator at the end of the October from BIFOR. So from next month, we start the validation process for the microwave cavity. Our final goal is obviously, as I said, we are trying to develop the lunar construction process. But to do that, we have to send these payloads on the lunar surface and do the more dedicated experiment to get more accurate data. So then we can apply this this information to build a microwave heating-based 3D printing process for our future habitat. So that's all for me. Thank you. Thank you for listening.